Good morning to all. In this video, we will discuss about the problem on limits and fits. Let's see the problem. A hole and mating shaft are to have a nominal assembly size of 40 mm. The assembly is to have a maximum clearance of 0.15 mm and a minimum clearance of 0.05 mm. The hole tolerance is 1.5 times of shaft tolerance. Determine the limits for both hole and shaft by using hole basis system and the shaft basis system. First we will determine the limits for hole and shaft by using the hole basis system. So first we should have to know what is the hole basis system. In the hole basis system, lower deviation of the hole is 0, which means lower limit of the hole is the same as the basic size. So this is the schematic representation of the hole basis system for various types of the fits. Let's observe the data. It is given that when the nominal size is the 40 mm and also given that when the maximum clearance is 0.15 mm and minimum clearance is 0.05 mm. From the data we can say that when the given type of fit is clearance fit. So this is the schematic representation of the clearance fit for the hole basis system. And also we know that when the maximum clearance equal to the hole tolerance plus minimum clearance plus shaft tolerance. So maximum clearance equal to the hole tolerance plus minimum clearance plus shaft tolerance. So in the data it is given that when the maximum clearance equal to the 0.15 mm. And one more thing also given in the data, hole tolerance equal to the 1.5 times of the shaft tolerance. Then we have to insert the data in the maximum clearance relation, that is the maximum clearance equal to the 0.15 mm equal to hole tolerance is the 1.5 times of the shaft tolerance plus minimum clearance that is given 0.05 plus shaft tolerance. From this equation we can determine the shaft tolerance, that is the shaft tolerance equal to the 0.1 divided by 2.5, which will give the 0.04 mm. So we know the relationship between the hole tolerance and the shaft tolerance, that is the hole tolerance equal to the 1.5 times of the shaft tolerance. We know the shaft tolerance, that is the 0.04 mm. Then we can determine the hole tolerance, that is the 0.04 into 1.5, that is the hole tolerance will equal to the 0.06 mm. Next we determine the limits of the hole, that is the lower limit of the hole as well as higher limit of the hole. We know the lower limit of the hole in the hole basis system is equal to the basic size. So basic size is given the 40 mm. So lower limit of the hole equal to the 40 mm. And the higher limit of the hole equal to the lower limit of the hole plus tolerance, hole tolerance. We know the lower limit of the hole as well as hole tolerance. Then the higher limit of the hole equal to the, so lower limit of the hole, that is the 40 mm plus hole tolerance, that is the 0.06 mm. Then higher limit of the hole equal to the 40.06 mm. Then the limits of the hole are lower limit of the hole is 40 mm and the upper limit of the hole is 40.06 mm. Next we will determine the limits for the shaft. For this one we will be use the one more relation, that is the minimum clearance. We know the minimum clearance equal to the lower limit of the hole minus higher limit of the shaft. Here we know the minimum clearance as well as we know the lower limit of the hole. Then the higher limit of the hole, which is equal to the, so lower limit of the hole minus minimum clearance, that is the 40 minus 0.05 mm. So higher limit of the shaft equal to 39.95. We know the shaft tolerance and also we know the higher limit of the shaft. Then the lower limit of the shaft equal to the higher limit of the shaft minus shaft tolerance. That is the lower limit of the shaft equal to 39.95 minus 0.04. So which is equal to the 39.91 mm. So limits of the shafts are lower limit that is the 39.95 mm, sorry, higher limit is the 39.95 mm and the lower limit equal to the 39.91 mm. Next we determine the lower limit and upper limit of the hole and shaft by using the shaft basis system. We know that in the shaft basis system, upper deviation of the shaft is 0, which means higher limit of the shaft is the same as the basic size. It is given in the data. Nominal size or basic size equal to the 40 mm. Then the higher limit of the shaft equal to the 40 mm. Next we determine the lower limit of the shaft, which is equal to the higher limit of the shaft minus shaft tolerance. In the previously we determined the shaft tolerance, that value is the 0.04 mm. Then the lower limit of the shaft equal to the higher limit of the shaft minus hole tolerance, which is equal to the 40 minus 0.04 mm, that is the 39.96 mm. Next we determine the limits for the hole. For this one we will use the relationship, that is the maximum clearance. We know the maximum clearance is equal to the higher limit of the hole minus lower limit of the shaft. In the data it is given that the maximum clearance equal to the 0.15 mm and we determine the lower limit of the shaft equal to the 39.96 mm. Then the higher limit of the hole equal to the lower limit of the shaft, that is 39.96 plus maximum clearance, that is the 0.15 mm. Then the higher limit of the hole equal to 40.11 mm. Next we determine the lower limit of the hole. We know that the lower limit of the hole equal to the higher limit of the hole minus hole tolerance. We know the higher limit of the hole, that is the 40.11 mm, and also we know that the hole tolerance, that is the 0.06 mm. So lower limit of the hole equal to the higher limit of the hole, that is the 40.1 mm minus hole tolerance, that is the 0.06 mm. Then the lower limit of the hole equal to 40.1 minus 0.06 mm, that is equal to the 40.04 mm. So this is the solution. Thank you.